printing news unpeeled with yours peels. Today we're going to be looking at Seawalls that are 3D printed. Phrozen joins the Material Extrusion 3D printing game, and I think probably the worst name I've ever heard for any kind of company. So first, let's start with Kind Designs. So Kind Designs is a company, and they want to make 3D printed seawalls. Now, there's a bunch of people doing this. You can pretty much make a seawall out of anything. And there are people that have in the past dumped tires and trains and battleships in the ocean in the hope of creating marine habitat from it with varying degrees of success. There's been a lot of talk about 3D printed seawalls. The idea is that it's more sustainable, and the idea is that it can be engineered to be more valuable. So we can engineer a lot of texture, we can engineer a particular material to be the perfect habitat for fish and marine life. And at the same time, it could be a functional seawall, helping against storm surges or flooding or any kind of erosion or any kind of activity. Now, the idea of having something that's eco-friendly at the same time promotes marine life and then also is good to protect against storms is, of course, very viable. We don't know if this is true, but a whole bunch of teams worldwide have done this. It's always gotten a lot of press, and Kind Design seems to really want to press this to the next level. They're using just a regular extrusion concrete 3D printer at the moment, and they make 10-foot panels in an hour. Of course, to dry out these panels is going to take considerably longer, but that's a pretty darn efficient process. They want to mass produce these things in Florida. Now, of course, that's going to be one of the areas where there's going to be considerable demand for seawalls and any kind of sea fortification. So that's a very, very good decision. And yeah, this is one of these things that people treat as kind of like being a fun thing. Bud? Oh, sorry. Sorry, I just sneezed. Sorry about that. Apologies. But people treat this as a fun thing, kind of an eco warrior thing. But this could very well, for a lot of municipalities who are under threat from the ocean, be something that can very quickly rebuild a seawall and maybe even do this in a better way. So I'm putting putting a little bit more attention on this and saying, hey guys, there might be something here. This is not just this is a very effective way of making a seawall type structure, and it may very well be very advantageous at the same time. The next thing is from Phrozen. Now, Phrozen is they've made several hundred thousand, really, really inexpensive DLP, LCD, and other types of light-based vat polymerization systems. They've been very successful making these units, and people are really happy with them because they, as long as the light source is okay, the motion stage is all right, and they did some math correctly. Well, these things work quite well, actually. I have a couple of friends that are really happy with them, even though they retail for next to nothing. Now, in a kind of like what seems to be an unexpected move, Phrozen is now entering the FDM game, the Material Extrusion game. Now, of course, it's a little bit more difficult because you're making a printer where you have to engineer a motion stage that is cost effective and works well. You have to worry about the pressure buildup and the dynamics of printing using material extrusion, which is a very different process. There's a lot more moving parts in these printers. They're typically a lot more finicky, and a lot more can go wrong, really. But Elegoo did this as well. Elegoo was a big. They sold hundreds of thousands of DLP type printers, and all of a sudden they're trying to make an FDM system as well. So that means that the competitive space around this printers is heating up even more. Whereas before you had a bunch of the clone army or the clone wars, we had a bunch of guys that had basically they were just making slightly better or slightly cheaper, depending on their approach, versions of the Prusa MK3 kind of type printers. And then all of a sudden, of course, Bamboo Lab came in and upped the stakes. And this meant that, Creality had to do the K1, which again, another more software heavy, more feature rich printer. And other people are now deciding to join this game. I would be terrified of competing with Bamboo Labs, and also terrified of competing at a reinvigorated Creality. To be frank, these guys, they do a semi-credible printer that kind of works, most days, let's say, for $200. So if you mid them 4 times, 5 times as much money, they're going to do some really interesting stuff. Now, and I would be a bit reticent to join that fray and say, hey, you know what? We're going to compete head on with these guys. But the guys at Phrozen have done this with something that has, well, it looks a lot like a Bamboo Lab printer. It's got one of these material mixing stations on top. For the rest of it, it's a 300 by 300 and 300 millimeter build volume system. Dual extrusion. It's got its own slicing software, which shows that Phrozen and a lot of the other guys are moving much more into not only necessarily just picking back on existing slicing software, but trying to own that experience, trying to own Also more complex kind of interactions around extrusion, around wall slip, around these effects, what's going on in the nozzle and how it can influence it. This leans quite heavily on the bamboo lab printer. It doesn't seem to have a lot of the sophisticated features the bamboo lab thing has, and I doubt that they had, the amount of money to develop that thing. But still, at 849, this is something that people need to look at, and yeah, the who to thunk it, the material extrusion market is going to become more competitive around the $800 phase or price point. So that you know, people always I've been saying it, a lot of other people have been saying it, that the $200 printer makers would go and move up to the $1,200 segment and wipe out the $1,200 segment, and then all the guys at $1,200 previously. Would then either die or have to move up into the pro segment, and the pro segment kind of Walter guys would then again have to move up into kind of the Stratasys segment. That was kind of the orthodoxy so far. What I, for one, did not expect at all is that these SLA guys who had a nice, really quite quickly growing niche, like SLA desktop 3D printing, VAT polymerization desktop 3D printing, has exploded over the couple of years. It doesn't seem like it's slowing down, but these guys seem to think it's time to get into an even bigger space where it sells maybe 10 times as many printers a year. So that's a bit unexpected, and I cannot be more surprised that more and more people want to be in this space, because it seems like it's going to be a deadly competition. It's going to be really difficult for a lot of people to survive here. And it used to be that a lot of people thought maybe people would go into certain niches. You'd go into automotive, we'd go into marine or something like that. That doesn't seem to be happening. These guys are all going to try and compete directly on for the $1,000 3D printer with a lot of features, with color mixing, with a lot of software. So let's see how that ends up. I think for us, it'll be good. For us as users, I think we'll end up getting better printers for this, more reliable printers that could very well usher in a consumer 3D printing revolution. And, everybody kind of thinks, before everybody thought it was going to happen, and now it's no one thinks it's going to happen. But I think if these devices become a little bit cheaper and as sophisticated as the bamboo labs, and we have a bunch to choose from, and these guys get better and better and better, well, then we could have a point where most people could use these things quite fairly regularly. Now, will they? I don't know. What are they going to make with them? How do we give them the creativity? How do we make software as easy as just pushing a few buttons? There's still a lot of things happening there. Hey, but we're selling like 5-6 million of these systems a year, so that's still quite a considerable number, let's say. Yeah. So the next thing is, oh God, it's Solvay. So Solvay has split itself into two, and the 3D printing part is going to go to something called Syensqo. I don't know. I think it's the worst name. I don't want to mean to pick on these guys, but this is literally the worst name I've ever heard of any company. I remember like a really, really long time ago, there was like a Vodafone product which was something to do with like faxing, and that was called Zoip. And I still don't know how to spell that, right? But the thing with this is this Syensqo. I don't know how to spell this. How would you spell Syensqo? If I told you that I was going to do business with a company called Syensqo, how would you spell that, right? What would you say, right? Would you spell it like this? Did you? Would you spell it like that? I wouldn't spell it like that. Like, first off, there's an I or a J, right? Or an IJ, or this kind of Y, right? And then the cis and co could be on the end there. It could be a C, it could be a CK, it could be a K. There's lots of options here. So, and then the beginning, it could also be like a C instead of like an S, maybe. So this is just the most confusing name ever. I think I really do not love this. But okay, the good news for 3D printing is, okay, Solvay was a pretty big materials company, and where they put a lot of effort initially into making filament, PEKK and PEEK filaments, and they allowed you to buy them with a biocompatibility kind of rating, which allowed you to make things to put in the body. Now, PEKK and PEEK are PEKK type, family type materials, which have really, really exciting properties. These materials are very, very strong, very tough. They're flame retardant. They can be used in things like aerospace, or really, really functional, really, really tough parts. And they could be, under the right conditions, can be biocompatible materials that you can implant into people's bodies. Now, the idea of going from material and certifying it as being something that you can implant in a body, and then actually coming up with the procedures that can let people actually do this in a safe way, is very complicated. There's a lot of liability. It's really scary for a lot of companies. Think about, for example, a company like Dow that really, really suffered and almost kind of went out of business over like a breast implant kind of material thing that they did and end up doing incorrectly. Um, that's a big thing. So not a lot of companies are very comfortable making things that go in the body. But we need this. There's a lot of researchers. There's a lot of companies out there that are making implants or trying to make implants. Now, PEEK and PEKK are some of the most interesting materials. If you need a polymer implant that's very functional, very strong, like a cranial implant, for example, and PEEK and PEKK are some of the materials that you really, really want to use. PEEK is the most well-known one. PEKK is a more newer material. Actually, PEKK has some really interesting characteristics. There's some grades of this material that are actually much easier to print than PEEK. If you're looking at a material extrusion kind of grade of printing this material, it's actually very difficult to get it to crystallize properly. It's very difficult to get it to perform properly, get the actual properties that you want from it. And as a powder bed fusion material, as a powder, it's actually really difficult to make because the usually, of course, you harden part of it and then the other part remains as a powder, and you can then reuse this other loose powder to a certain extent. And that percentage, of course, really, really like affects how much the part is going to cost ultimately. Imagine you can recycle 80% of this material a couple of times. That's great, but if you can never recycle it, like in some cases with some medical device stuff, or in this case with using PEEK in this fashion, it's going to be super expensive. This material costs hundreds of dollars a kilo of PEEK and PEKK, kind of because there's a shortage, kind of because it's difficult to make and it's more specialized, and kind of also because it's a really nice moneymaker for these guys. Um, and also because, like, they try to, say bulk is really widely available and costs 1 cent. Engineering plastics is $6 to $20 and costs and is less available and more higher performing. And these are like these ultra polymers or high performance polymers that are the top of the pyramid. So they're going to value price them in this sense. And when a whole bunch of time, in terms of something like continuous service temperature, in terms of when all the other polymers kind of give up, you've got polyimide, you've got Ultem. There's a couple of really high performance materials, and one of them is this PEKK family that is kind of always at the top of this. So that's probably why they're pricing that much. Now, this is great, but not a lot of people are trying to make them available for biocompatibility. Victrex, which is a big producer of PEEK, is basically said, you know what, you can buy the powder from us, you can buy the filament from us, great stuff, go for it. But you can't get it certified, or we want to make these medical parts ourselves. Actually, other material vendors have just not been they've been a little bit more scared of this, essentially. So with Solvay, the important role they played, they didn't have a giant portfolio of material. They had some really interesting, really very well targeted materials, and some of these were really kind of the ones you could use, and with a reasonable expectation of being able to make a medical device out of them or an implant out of them in polymers out of PEEK or PEKK. And now they kind of they were on top of things, and they were really, really investing a lot of effort into to making these materials available. And then they kind of were aloof, essentially, for a while. It wasn't a priority anymore. And now, hopefully, under this Syensqo, tell me in the comments how you think you should pronounce this. Syensqo? Syensqo. I think it's Syensqo. Or Syensqo? Syensqo? I have no idea. It sounds like it's some disease or something, or like some alien planet or something. I don't know. Anyway, so under this Syensqo company, whatever they're called, maybe they'll get a lot more energy, they'll get a lot more more development, and really we'll see these materials end up in a lot of labs, and this will really help research into these materials a lot more, because they are so far we've seen a lot of titanium implants in the body. There's some work being done on CMF, this cranial maxillofacial implants using various materials, and there's cranial and CMF implants using PEEK and PEKK and stuff like this. But there could be in trauma and cancer and any kind of area like that. There's a ton of areas where a polymer implant would make sense, and custom polymer implants would make sense. Think of cranial maxillofacial CMF implants, where somebody has a very unique accident or a very unique congenital kind of defect, and you're trying to repair that. That's unique for that person. It's unique for my face if they have to repair that in a certain way, even unique for my half of my face. And there, these kind of materials really make a lot of sense. Even though, of course, it's never a really good idea to put polymers in the body for a really long time, and there've been things that have gone horribly wrong with that in the past. But so we should be a little bit careful. But this is still a huge opportunity for Syensqo, and yeah, I hope they grab it with both arms, because yeah, it really could use a lot more work and could do a lot more good for all of us. Anyway, my name is Joris Peels. I hope you found this very, very exciting and very, very useful, and thank you very much.